Hello friends, our next topic is delta modulation or DM. In last video lecture, we have discussed pulse code modulation system. In PCM, many operations are involved such as encoding, decoding, quantizing, etc. and form a complex circuit. So, its practical implementation is very costly. And we move to another digital pulse communication technique which is more efficient or less costly as compared to PCM, and this technique is called delta modulation. In delta modulation, incoming modulating signal MT is oversampled, that is, sampling frequency Fs is far greater than twice of Fm. This oversampling increases the correlation between adjacent samples of discrete signal, that is shown in figure. Here, the samples at adjacent sampling instant, that is Ts, 2Ts, 3Ts, are correlated with each other and permits the use of simple quantization technique. Correlation between different samples means the signal does not change rapidly from one sample to the next. So, using oversampling in delta modulation, encoded signals are generated using simple quantization circuit. On the basis of operation, in delta modulation, oversampled version of modulating signal MT get converted into staircase approximation, denoted by MQ function of t, which having only two quantized level plus delta and minus delta that correspond to positive or negative differences. If the quantized approximation, that is MQT, is less than MT, the level is increased by delta, and if the quantized approximation is greater than modulating signal MT, the level is decreased by delta, that is shown in figure. Here, for the first quantized approximation, level is less than amplitude of modulating signal MT, so the delta modulated output is symbol 0. And for second, third, fourth and fifth, the approximate level is greater than modulating signal MT, and in this case delta modulated output is symbol 1. And accordingly, the approximated level increase or decrease by plus minus delta correspond to the amplitude level of modulating signal MT. Now, the basic principle of delta modulation is described by the following three sets of discrete time relations, and these are: first is error signal, that is E function of NTS, it is equals to M function of NTS minus MQ function of NTS minus TS. Here, M NTS is called present sample value of modulating signal MT, and MQ NTS minus TS is called latest approximation of sampled version of MT. So the error signal for delta modulation is denoted by E, and it is the difference of present sample value of modulating signal minus latest approximation of sampled version of modulating signal MT. Second relation is quantized error signal, denoted by E suffix Q, and it is equals to delta signum E function of NTS. Here, signum function having assigned value of plus minus 1. And the third relation is quantized modulating signal MQ function of NTS, and it is equals to MQ NTS minus TS plus EQ NTS. Here the first term is called latest approximation of sampled version of modulating signal, and the second is called quantized error signal. So these are the three sets of discrete time relation that describe the operation of delta modulation. So we use these three relations in our discussion. Here we note a point: in delta modulation, information is transmitted with the rate of sampling frequency, and it is equals to 1 upon Ts, and this is called sampling rate. The block diagram of DM transmitter is shown in figure. This DM transmitter is based on the set of 3 discrete time relations. DM transmitter consists of comparator, quantizer and accumulator. An accumulator is composed of adder and delay Ts, that is sampling period. So, here the comparator compares the input sampled signal, that is M and Ts, with the latest approximation of sampled version of modulating signal, and it is MQ and Ts minus Ts. And this comparator generates an error signal E and Ts. This error signal is passed through the quantizer having a scaled version of signum function called hard limiter. The output of the quantizer is the quantized version of error signal called E suffix Q. This quantized error signal has 2 levels, minus delta for negative input and plus delta for positive input. Now we talk about functioning of accumulator in delta modulation. Accumulator operate on quantized error signal, that is EQ and Ts, and produce a latest approximation of sampled version of modulating signal, that is MQ and Ts minus Ts. This accumulator is composed of delay and adder. Let us assume that accumulator process start at t equals to 0 and quantized modulating signal MQ and Ts is equals to MQ and Ts minus Ts plus EQ and Ts. This quantized error signal is equal to delta signum of E and Ts. And in place of E and Ts, we can write M and Ts minus MQ and Ts minus Ts. Now, if error signal E and Ts is positive, latest approximation is less than M and Ts, and level is increased by delta in positive direction. Also, if error signal is negative, the approximation, that is MQ and Ts minus Ts, is greater than M and Ts, and the corresponding level is incremented by delta in negative direction. So there is a perfect accumulation, and quantized signal track the input signal by plus delta or minus delta, that is one step at a time. In DM transmitter, accumulator works on quantized error signal and produce the latest approximation MQ and Ts minus Ts corresponding to the sampled version M and Ts. Next, quantizer output, that is EQ and Ts, is encoded into a unique bit of sequence. This DM data sequence is transmitted via a channel and received by DM receiver, which consists of decoder, accumulator and low pass filter. Now, at the DM receiver, input data sequence is first decoded and get converted into plus minus delta corresponding to positive or negative pulse. Here, accumulator consists of adder and delay Ts, which generates a staircase approximation MQT, in addition to the quantization noise in high frequency component, that is called quantization error. And in order to recover original modulating signal MT, we simply use a low pass filter which having a bandwidth equal to the message bandwidth, that is FM. But this DM technique is influenced by 2 types of quantization error. First is called slope overload error and second is called granular noise. So we are going to discuss these quantization error in our next lecture.